Hello, everyone. I hope you can all hear me well. Um, my name is Yasin, and I will be your host for this session. It's my pleasure to welcome you to the latest GraphWise webinar with a topic, Get AI Ready with Graph Center of Excellence. Today, joining me are Sumit Pao, who is the Strategic Technology Director at GraphWise, and Brandon Richards, who is General Manager for the APAC region, again at GraphWise. Before giving them the floor, I would quickly like to say a few housekeeping items that I think are important. First of all, this session is being recorded, and a link to the recording will be available to everyone and will be distributed most likely in the next day. So you can look over for this. Other than this, you are all muted, and that is to avoid background noises and also to enable the speakers to present without any interruptions. However, if you want, and we actually encourage you to communicate with us by using the box in your GoToWebinar panel. At the end of this session, we have planned a short 10 minutes Q&A in which we will try to address all of your questions. In case we don't have the time to address all of them, we'll make sure to answer each and every one on email. With this, I would like to give the floor now to Sumit and Brandon, who will begin the actual presentation. So I think, Brandon, you start, so the floor is yours.
Great. So hopefully you can see my screen.
Yep.
All right. Well, thank you, everyone. My name is Brandon Richards. I'm the General Manager for APAC at GraphWise. And I've been, just a little background on myself, I've been working in the graph domain for the last 9+ years, helping companies across the world and more recently across all of Asia Pacific on their graph journey. And I'll let Sumit can introduce himself. Yeah.
Sure. Thank you, Yasin. Thank you, Brandon, and thank you everyone for joining. We're delighted to have you here. My name is Sumit, and I am an ex-Gartner analyst. And my role here at GraphWise is to evangelize and build thought leadership across various industries for adoption of knowledge graph and semantic technologies. My background, I've been a software developer, a data engineer, a data architect for a long time. I've also published a book, and I've been doing graphs since the last millennium when I did graph theory as a part of my bachelor's as well as my master's in computer science. I am the collaborator and sort of a non-hallucinating co-pilot with Brandon in developing this graph center of excellence. So Brandon, let's take off.
Yeah, so thanks, Sumit. So we've titled the webinar, Get AI Ready with a Graph Center of Excellence, Rethinking Enterprise Data Management for the Age of AI. And I hope we won't disappoint today. I think we've put a lot of thought into this. Let's jump to the first slide. So as I mentioned before, I've been working in the graph space for the last 9+ years and talking to a lot of companies on their journey, their graph journey. And I've come across kind of these 3 different groups who right now are thinking about, exploring, trying to determine whether a graph center of excellence is something that might be a good fit for them. And I would put these into 3 categories. So the first is the graph early adopters. So these are people who've experimented, they've done maybe a few graph projects, built a knowledge graph and seen success. And they're at that point where they feel like they get it, they see the value, they want to go all in. And so building a graph center of excellence makes a lot of sense. They want to have a little bit more of a strategic approach to how they're thinking about graphs in their organization. The second group is the AI readiness group, the crowd, right? So these are people who have come to the realization in the last year to 2 years that AI is upon us, right? They realize that AI is a very disruptive potential across different businesses and industries, and they need to get they need to get their act in order, right? They need to become more AI ready. And so this group is looking at how can we prepare our data and get our data AI ready by connecting, contextualizing, democratizing, and enriching our data. And so that's one of the second group. The third group is the group that's more interested in kind of the next generation data management. So they are wanting to modernize, streamline, simplify, as I say here in the slide, their data management, their governance, how they integrate data. And the primary objective is they want to overcome what we call the bad data tax. And we've done other publications and webinars on the bad data tax. But basically, the idea that not having your data in order, in proper order, is costing you a significant amount of money. And every year you're paying that, whether you like it or not. So the group that wants to overcome that, they think that a Graph Center of Excellence might be able to help resolve that issue. Now, depending on which group you fall into, you may have different levels of understanding of graph technology. So I thought it might be helpful to have a quick recap of what we're talking about when we're talking about graph technologies. So firstly, every organization, if you think about a data maturity spectrum, every organization is somewhere on this spectrum, and they're trying to become more mature, so progress to kind of the next stage. And almost everyone that I talk to is stuck at this information stage. At least as an organization, they're stuck at information. They may have little pockets or a particular use case that might be kind of further along in the knowledge, insight, wisdom. But generally, as an organization, they're stuck at kind of the information stage. And the only way to get towards knowledge, insight, and wisdom is to connect the dots across your data. And this is where graph technologies come in. Graph technologies help you connect those dots across the data. The other key piece is with graph technologies is you're allowed to or enabled to contextualize your data with semantics. And this includes adding structure in the form of things like hierarchies and ontologies, taxonomies, how you classify data. So it's the structure, the context, and the meaning with the data. So not only are we connecting the dots, but we're giving it that additional level of structure. And as a couple of little examples, something is a subclass of something else, which is a subclass of something else, or something is a part of something else. Being able to capture this is really useful. And to illustrate that, I want to talk a little bit about semantic ontologies and how they give meaning within a particular domain. And this is just one quick example. So in this example, a professor is a type of teacher, and a teacher is a type of profession within the education system industry. And a teacher teaches a student, and the student attends a school, and a university is a type of school. Now, as I kind of walk through some of that, you're probably thinking, well, that's obvious. Everybody already knows that. And that's part of the problem, is that we, as humans, we have all of this context that we understand just by living in our world. But machines don't have that context. And the idea behind semantic ontologies is we can make this context machine interpretable so that the machine understands the semantic meaning of different things and how they're related. So you can think of how this might apply in the AI space, right? Where if you just want to feed discrete data to your model, it's not going to have the same outcomes as a machine that kind of understands the contextual information around what the meaning of those things are. So that's the second piece. And the third piece, I'll let Sumit cover this one.
Sure. Thank you, Brandon. And yeah, just to reinforce what Brandon was saying in the last two slides about context and semantics, right? Context and semantic, something that is very obvious to us is missing in the raw data for machines to interpret it. And that is where ontologies, taxonomies provide the necessary semantics, context, and meaning to the data elements for machine interpretability, right? Because data in and by itself is just a series of text or numbers, but it's the context that makes it more valuable. And graph technologies, by connecting the different pieces where the context is also sort of siloed, fragmented, brings this paradigm shift from we all organizations want to become data driven, but there is an additional piece that is missing, which is becoming context driven analytics, context driven pipelines, right? And this context needs to be embedded in data and the AI pipelines to answer end user questions with trust and with confidence. Like the example Brandon was showing, to take it further about the ontologies and taxonomies, think about this relationship, the spouse relationship, right? Spouse relationship is sort of a bi-directional relationship. A is a spouse of B, also implies B is a spouse of A. But in the way we are solving the problems today, we have to encode that information within our data sets. If we use knowledge graphs where the ontologies and taxonomies are well defined, there are a lot of publicly available ontologies and taxonomies that can be easily integrated into a knowledge graph. The knowledge graph brings that bidirectional relationship inherently. You don't have to encode it. Traditional ETL data engineers encode that kind of an information, but with graph-based technologies, we come to something called ECL, which I say as extract, contextualize, and load. And this leverages the semantic metadata for facilitating data connections. Now, we all have heard about data lakes, data warehouses. A lot of the data lakes fail, right? Data is getting increasingly harder to find. LLMs hallucinate. The reason is the lack of context, the lack of semantics. One of the reasons is in traditional organizations, we have let transactional and analytical systems be semantically isolated. And that has allowed data to lose its consistency and precision of meaning. Semantics is the missing piece for most organizations in their data management strategies. Semantics are imperative to understand and describe data, how the data is related across the silos unambiguously, for exchanging of data, for sharing and reusing. And these kind of semantic layer, the semantic data integration, which is powered by a knowledge graph, the semantic models connect the user intent, the user question, with context to the actual data. Because without semantics, there is a huge risk of losing valuable information when data engineers sort of do their ETL or ELT to enrich the data. Luckily, and what has been happening is a lot of organizations have been ignoring semantics, the semantic layer, right? Thinking, semantic layer becomes semantic later. We'll do it later, right? However, there is a change happening, which I see, where organizations are understanding the value of the semantic layer. The semantic layer adds that meaning and context to the data elements by representing data assets as entities, data assets like entities, dimensions, relationships in a business consumable form. GraphWise, some of the biggest customers of GraphWise, who are the adopters of semantic technology, have tried mainstream data management technologies and recognized the most important need for them is to have the semantics to improve their efficiency and competitiveness. And the semantic helps organizations in three basic ways. First, it helps with integration of the data by mapping data to a shared semantic model. It improves the data quality by improving and bringing in additional inherent relationships between the entities. And both these lead to trust, because not only now you can get increased trust if you incorporate semantics that comes from shared models, but you also get a lot of data validation, things like data lineage and provenance with knowledge graphs. And a knowledge graph that is built on with semantic technologies, for example, you cannot ingest duplicate data. And we know a lot of organizations spend an inordinate amount of time to remove duplicates in their systems. So the semantic layer with semantic data integration brings in a lot of benefits in terms of it becomes machine interpretable, it follows open standards, and because it's based on graph, it's very flexible. You can accommodate new changes in schema as your domain grows. Yeah, Brandon, maybe the next slide where we talk about, I think, the bad data tax. Or yeah, this is a quote from some of the leading analysts in Gartner about how data silos have become entrenched into most organizations, limiting their ability to draw insights from data, and also why the next generation data management highly needs semantic modeling, semantic-based approach to doing your data management practices, to building your pipelines, to incorporating context within your data pipelines and your AI pipelines. Now, Brandon sort of alluded a little bit in the earlier slides about the bad data tax, right? We have written extensively about it. What has happened is, in this mad rush to become data-driven, most organizations and data teams have created sort of a tangled web of data integrations, right, and reconciliations across data silos. And this has often resulted in organizations spending about 40 to 60% of your technology budget, which often runs into millions. And this is called the bad data tax. And these investments often, don't translate into key insights that are needed for delivering better business outcomes or building efficient processes. So this is a solid justification for every organization to fix the data. For consumers who need access to the data to convert it to insights and to drive business decisions. The data needs to be available, accessible in a format that is flexible, that is machine readable, and it should also retain the context of the original data and also allow traceability as data flows through the organizations. So rather than stepping back and fixing data problems, what most organizations have done is they have built workarounds, they have done band-aids, duct tape-like solutions. And if you think bad data tax will only worsen as organizations jump to build Gen AI solutions or AI solutions and start working with a lot more unstructured data, which comprises almost about 70 to 80% of an organization's data assets. Most organizations today, which what I'm seeing is they do not have much enough idea about the data quality of their unstructured data. So organizations should not be building point-to-point integrations and should build integrations once that is powered by a semantic layer and reuse. Reusing is the key. And building that foundational semantic graph layer is, with the knowledge graph, is one of the approaches organizations should do to avoid the bad data tax going forward. Yes, Brandon.
All right. So I think the bad data tax aspect for me is particularly interesting because everyone who's trying to advocate for using graph or a broader adoption of graph, they end up having to come up with some kind of a business justification. And if you're looking for that, this could be your golden ticket, right? The use case around solving the bad data tax can that alone has a very strong ROI. But to kind of summarize what the value drivers were, right? So we've got the connecting the dots is one of the key things that graph technologies enable, and that delivers new insights faster. Usually the types of questions that you were previously impossible to answer, right? So it's going to give you those new insights and new key insights faster. Contextualizing your data and you're going to get your better AI outcomes. And it's not just AI, it's also data science, right? And then the third one is the data integration piece, where you're using semantic data fabrics, data virtualization, simplified governance, and that's going to deliver those massive cost savings. So with that context, we see also Gartner talking about all the different AI techniques, and they place graph in kind of this one of the techniques and practices that is broadly used with AI. But as you read different Gartner reports or different analyst reports, you're going to see several terms thrown around pretty loosely. And one of those is graph technologies. Another one is knowledge graphs. Another is semantic layer. And I think it's helpful for you to understand that all of these, we're talking about kind of the same thing. So how these are all used very tightly together. So the key benefits: connect the dots across your data, give machines human-like context, increase the accuracy of AI and large language models, add AI explainability, which we haven't really talked about yet, but that's another key element that knowledge graphs are able to do. Enable you to talk to your data, which is always really cool, and then automate processes. So what's the point in doing all of this stuff if we can't automate that and integrate it into our business processes, right? So that's kind of the key value that you're getting from graph technologies. A couple of quick quotes from Gartner. Using graph techniques at scale will form the foundation of modern data and analytics. They first said this in May 2020, and I think they've repeated it 20-something, 30-something times since then. So this is a really powerful statement about it being the foundation of modern data and analytics. The next one, also from 2021, but they say by 2025, graph technologies will be used in 80% of data and analytics innovations. And they've repeated this over and over again, even as recently as last year, talking about how when you're looking at data innovations, that it's going to be coming from those connections in the data that being enabled by graph technologies. And then we also get their impact radars, and these are impact radars from 2024 showing how graph technologies have suddenly, especially with AI and everything that's happening with AI, have kind of moved front and center to these impact radars. So we see it listed at the center of the impact radar on critical enablers. This other one that has data-centric AI technologies, where it's at the center of that one. We've got impact radar for generative AI, where knowledge graphs are again at the center of that. And then talking about semantic technologies around data for Gen AI, augmented data management. Sumit, did you want to comment on this from your old friends at Gartner?
Sure. Thank you, Brandon, for reinforcing this. And for organizations to be successful with their AI endeavors, they must first, in my opinion, be successful with their data management practices, right? And making a leap to Gen AI is not just about deploying a chatbot, right? It requires the reshaping of the foundational aspects of your data management. And what basically Gartner has been saying and reinforcing is that organizations prioritize a comprehensive and reliable data foundation to help guide decision making and the data strategy development. Because as organizations embrace AI, trust must be at their top priority. And to bring in trust with AI, they must first instill trust in the data that powers it, right? Because again, in my opinion, AI is only as good as the data management practices and data that it trains on, right? And in my opinion, there are three main reasons why knowledge graphs are proving so valuable, and Gartner is reiterating them, is that without knowledge graphs, organizations risk missing out on semantics and data quality to control the risks associated with it. By unwittingly sort of training AI models and LLMs on contextually irrelevant data, worsening your hallucinations, right? And this will cause money and cause a lot of irreparable reputational damage. The other reason is about regulations, right? Legislations like EU Act and detailed scrutiny with the regulated industries have made explainable AI an essential prerequisite for enterprises to launch AI applications or to build AI applications. And knowledge graphs, as we say here within GraphWise, is the GPS for AI and LLMs. They provide a clear route, accurate directions, and the context to navigate, right? We have built-in explainability in our graph RAG systems, where you can, when you ask, like one of the things Brandon showed about talk to your graph, when you ask a question, it comes back with answers, but we also show the traceability of where the answers are coming from, right? And the whole thing is, you cannot have an AI strategy without a data strategy, and enterprise CDOs are already in sort of this disillusionment phase of AI hype cycle, where it's not the lack of AI models, but it's the AI ready data that is causing a lot more challenges for them. Go ahead, Brandon.
All right, so hopefully that little reminder about all the different elements of graph technologies and how they come into play and how they'll interact in a graph center of excellence. Let's sink our teeth into the elements of a graph COE. The first one is the graph COE provides this ability to more strategically approach graphs. So here in our first group, right? So this is about the prioritization of use cases, along with the synergies that are going to be used across those use cases. So we're looking for those synergistic enhancements from one use case to another. And you want to be able to build the foundation incrementally while demonstrating wins along the way. And this is a really key factor. If you wanted to just take the time out, let's build out an entire graph foundation before you see any value, that would be a really tough pill to swallow for a lot of organizations. So we need to find a way to build that foundation but show value incrementally, and this is a key piece of what we'll be talking about today. The second one is we need a centralized team that is going to be able to implement best practices, right? So these are the specialized skill sets needed to deploy graph use cases. And the idea here is by specializing in graph, there will be economies of scale. So hopefully you will see the deployment speed improve, as well as the implementation of best practices. There's other areas of economies of scale that also apply, where you could get, for example, licensing of the technology. If you're doing that at kind of a centralized approach, you can get additional economies of scale from that. Education and collaboration. So this is a key piece of any successful graph COE, because ultimately every organization is going to have some degree of inertia that you have to overcome. And anytime you start bringing up a new technology or a new approach, you're going to hit some levels of resistance. So you need to educate and advocate use cases, what the value is going to be with a graph-based approach, help them understand what the differentiator of graph is. And you're going to focus on key stakeholders in the organization, especially data owners, application owners, and to some degree also end user business stakeholders, right? They have to understand what they're going to get out of making this move. But along those lines, you're going to need to find a sponsor and have some degree of authority. And this will also help overcome that organizational inertia. If you have buy-in and sponsorship from a C-level executive in particular, it's a lot easier for other individuals in the organization that are data owners to fall in line. and you've got a key initiative that you can point back to. So they're a lot more willing to listen and follow if they know that that it's a key initiative. Streamlined data governance. So this is a little bit like what we talked about, or what Sumit was talking about from the the streamlining of the data integration piece. So you want to modernize, streamline, simplify the data management and governance principles across the organization. And the purpose here is, if you can do that right at the graph level, that will automatically translate downstream to all the use cases downstream of that. So I think a lot of individuals, in fact, I've heard of some graph COE approaches where selling the idea to other data owners that you are going to help take care of the data governance headache. Oftentimes that alone is enough to have them buy into the graph COE. And then lastly, one of the key initiatives is to build a reusable foundational semantic graph layer. That's a bit of a mouthful. But the idea, again, this kind of comes back to that integration layer. But we don't just want it to be an integration layer. There has to be this reusability being kind of the key objective. So having shared graph models that are going to work across the organization is really important. Anything you want to add to any of these, Sumit? Any comments?
Yeah, the only thing I would add, Brandon, here is, overarching all this is, the key is to define a strategy for leveraging graphs across the organization by defining, the underlying drivers, things like cost containments, things like process automation, regulatory compliance, governance simplification, and then prioritizing use cases based on data integration, digitalization, or enterprise search, traceability, access controls. And also one of the end goals should be to create sort of a connected inventory of what data exists, how it's sort of classified, where it resides, who is responsible, how it is used, and how that data is moving across in a system, in an organization, across different systems. So yeah, that's how I would summarize it.
All right. So we're going to go into use case trees, which I think is an exciting topic, in a few minutes. We're going to pause now and go into graph COE roles and a little bit more in depth onto what some of those roles are. And I'll hand this over to you, Sumit.
Sure. So yes, building the Graph Center of Excellence needs a team actually that understands the different graph use cases within their domain and can communicate and evangelize it across the organization. A team that sort of possesses the technical skills to understand and capture the best practices around graph deployments. The key to all this is, of course, the C-suite sponsorship to bring in a broad consensus about graph as a strategic initiative for the organization, communicating the ROI of graph across the organization. The C-level team should act as sponsors of this graph COE to communicate the business priorities to the COE team. And it requires sort of an unquestioned mandate from the top to overcome this organizational inertia. And this is definitely one of the key things for everyone else in this role to succeed, right? Then there is the graph architect, who is sort of the key, plays a key leadership role in the Graph Center of Excellence. The graph architect should be experienced with graph and semantic technology deployments and use cases. The graph architect should be a visionary person who can easily identify the areas for deployment that span beyond the technical architecture, and also able to convey to the business stakeholders what new value and insights are possible through the graph approach. They should be capable of building the use case tree with the dependencies so that it promotes reusability, prioritizing the use cases, and of course, the graph architect must be an excellent communicator. The the role that is also equally crucial is the role of ontologists and taxonomies, who creates the knowledge models from industry standards, from internal organizational ontologies. And this requires a lot of domain expertise. They work with domain experts to craft and merge different ontologies, taxonomies, the vocabularies for a shared understanding of the domain concepts. And that is the key for building unambiguity around the data elements. Then, of course, there is the knowledge engineer, right, who serves as a major technical knowledge graph creator, determines what shared models to be built and what use cases are going to be used from those models. Of course, then is also the UI UX developer, who understands the business objectives, the project requirements, and deliver user interfaces, building semantic applications with the right user interface that maximize the adoption and the usability of them. And they, of course, should need to know things like graph visualization toolkits and how to blend them with traditional UI elements. And then there is the data and the application owner, who must also buy into the graph vision and work in conjunction to contextualize and link the data in the foundational semantic layer. And then, of course, there is the knowledge steward, or who I call also domain experts, who leverage their industry and vertical knowledge in collaborating with ontologists to bridge that gap between data, applications, and the business logic with the thread of the context and the semantics. And of course, last but not the least, the IT organization, right, that has the skill sets that are not specific to graphs. And the graph COE will rely on the IT organization for development, for data administration, and things like that, for building the IT infrastructure. Yes, go ahead, Brandon. I think.
All right. So we'll go ahead and jump into building a use case tree. And I think the goal of building a foundational layer that can serve all the downstream use cases, and again enabling synergies where they're possible, and part of the objective here is also to unlock value incrementally along the way. So this use case tree model the idea is it's providing kind of a framework for planning and prioritizing use cases. And so we have different components: the roots, the trunk, the larger branches, the smaller branches, and we'll go into each of those into greater detail. So firstly, we've got the roots. And the roots, the way we interpret this is these are kind of the core data management and governance principles that need to be applied across all of the semantic layers, the ontologies, the taxonomies, and so forth. So some of the principles are: data should be available and accessible. It should be stored in a flexible format that retains context and intent. It's traceable as it flows in, out, and within the organization. One of the keys here is that a strong root system is going to provide the nourishment, stability, and health to the rest of the tree. And if you get this part wrong, if you're not following proper data management and governance principles, that will impact the health of the tree, the whole tree. So things like access control, data lineage and provenance, metadata management, and more, all of this can be simplified when it's built into these shared graph models that are foundational to the tree at the root level. The next level is the trunk. So this is primarily all about integration, right? So it's the data integration layer that we've talked about, semantic data fabric that might start with our data catalogs and creating a data inventory of what we've got. But the models, the shared models and ontologies are going to have to focus on the reusability factor, right? Ensuring that they're able to be used for over and over again with downstream applications. So this will also incorporate things like identity resolution, using web standards, data validation. And for those who are real graph technology gurus, you're going to understand about the power of using, URIs, IRIs in resolving entities and such like and things like that. But this particular foundational semantic layer, this is the one that's going to help resolve the bad data tax that we talked about earlier. So your ability to build a justified business case is going to be, this is going to be super critical for that. Let's see. So in order to do this layer, this is where you're going to need the buy-in and participation from various data owners and application owners. And hopefully, as you can convey and teach the benefits of it, it will help with the level of adoption. But one of the kind of major hesitations that people have with this layer is that it can be this monumental task. I mean, depending on how much data you have as an organization, which it could be just massive, trying to tackle all of this at once is way too much. So the real key here is if you want to build momentum and score some incremental wins, trying to pause and build out an entire foundation is not a great strategy. So you're going to want to build incremental wins along the way. So just like a tree, if you kind of cut a tree and look at the cross sections, every year it adds a new ring in its growth. And similarly, this trunk doesn't have to be built out all at once. You can build out the portions that are needed and build it out incrementally, one layer at a time. And so the idea here is that if you can figure out what use cases, what the downstream use cases are that you feel are high priority, you can work backwards and figure out what portions of the foundation need to be built out to support that use case. And by taking this approach, you can build out the portion of the foundation that's needed while also showing value with those downstream use cases. So that's a strategy that we're seeing works quite well. Now, one of the rings, or some of the rings that could be a part of this, that may be tackled early on, or it could be tackled later on, is unstructured data. So depending on what data or the value of the data that resides in your unstructured data, a lot of organizations will choose to put this off because there's extra steps needed to build knowledge graphs with unstructured data. So they may want to put that off till later, and that's perfectly fine. Other organizations may have a wealth of knowledge that is mission critical in that unstructured data, and they may prioritize that and want to do that much sooner in the process. So depending on where the value of the unstructured data in your organization, this is something that can be just one of those layers that you add when it's the right time. And this can enable a lot of the use cases around things like enterprise search, chat bots. We get into things like people wanting to use large language models, like ChatGPT or Claude or Gemini or Grok or whatever. Any of the large language models, in order to really get value out of that, you're going to want to have this semantic layer built first. So we've talked a little bit, Summit hinted at the idea that hallucinations, explainability, accuracy all suffer with large language models. They'll answer every question whether they know the answer or not, right? So you want to have some explainability and increasing the accuracy, but also the relevancy of the answers. And all of that happens when you've got this semantic knowledge graph already built for that unstructured data. Building a use case tree with the large branches. Okay, so this is effectively kind of the consolidation, aggregation of data around certain themes. So it's a 360-degree view of X, like whatever, right? So you can call this X360, but it can be, I want a complete view of my IT systems, or I want a complete view of our products or our customers, or the supply chain, or people, processes, assets, like a digital twin of our assets. All of that is captured in kind of these large branches. And they can enable things like enterprise search and graph RAG, which is effectively an approach. It stands for graph retrieval augmented generation, which is basically, we want to insert graphs and knowledge graphs into that, the process of the LLM taking the questions and answering the questions. We're going to kind of insert the knowledge graph in the middle of that to improve the accuracy and relevancy, adding that explainability, and also the data governance, which we didn't mention before. But you know, if you just hand it over to an LLM, it has no sense of data governance or what information should be shared, and that's also managed at the graph level. And the last piece are the small branches, and these are those downstream use cases. And usually, this is you know, where we're starting to address some of those key business questions, the types of questions that you couldn't answer previously, right? They were impossible previously. So graphs enable you to ask those really interesting, you know, killer business questions that that are challenging, and to be able to get those answers very quickly. So when you extract new insight from those, you know, the consolidated X360 type, you know, larger branches, it opens up all kinds of new doors of what you can do with, you know, creating data products, analytics, reporting. It also opens new doors for making predictions, you know, recommendations, and you know, how you might optimize different things. And then, you know, wanting to integrate and integrate those and automate those processes into our business. So what we found is that this there's kind of a pattern that we follow in these use cases, and it kind of starts with the data aggregation and linking, and then, you know, once you've aggregated and linked your data, then you can start to search and do analytics on top of that. And then when you have the search and analytics use cases built, you can start to move into the prediction use cases. You know, what you know, where you're using graph analytics, graph techniques to predict things, and then and as well as AI and, you know, other data science techniques based on top of those the knowledge graphs you've built. And then lastly, are automation use cases, where you're actually putting them into business processes. I'll give you an example of you know, how this works. So one example is kind of like a customer 360. So I might want to add additional data that might not normally be part of a customer 360. You know, it could be transactional data, time series, clickstream data, you know, how they're interacting on our website, how our customers are interacting with us, servicing processes, events. So we can pull all this into kind of a you know, one large X3, you know, customer 360 knowledge graph. And then that opens up, you know, depending on what the KPIs are for, you know, sales, service, marketing, I can start to drive the types of, answer the questions that are of high value to those different organizations. And again, those are the questions that we just couldn't get answered before, because you know, the answer was hidden in these connections, right? What we couldn't get before. We can get into things like customer journey analytics use cases, and that might translate into some things as we get into the prediction use cases, where we want to start, you know, predicting churn, or predicting what products a customer might want, or what marketing offers, what's the next best offer. There's also, management reporting is a part of the search and analytics, dashboards, those kinds of things. Compliance use cases, you can think of GDPR or others that might be interesting in the customer 360 realm. But when we get into the prediction use cases, now we're doing product recommendations, as I mentioned, marketing offers, churn analysis. Based on the customer journey analytics, are there certain behaviors, oops, it's jumped ahead, are there certain behaviors that will help us predict when a customer is going to churn? And are there things we can do to insert ourselves in that process and prevent the churn? And so once you start to identify what those are in the prediction use cases, you want to start to implement those and automate those in real time. So, so rather than just getting that insight and having to try and manually deal with that, if you can build automated processes, that's kind of the goal here. So building the business case, I wanted to segment it back into our three main areas. So connecting the dots, getting the new insights faster. This is a, we want to become a data-driven and context-driven organization. And so this is one of the key values that you're able to deliver with Graph Technologies and a Graph Center of Excellence, answering those high-value questions that were previously impossible. The challenge from a business case standpoint is this is really only quantifiable on a use case by use case basis. So depending on the specific questions that we're answering, what value do those answers provide to the organization? And as we do that, we can build a use case around a specific use case. Build a business case around a specific use case. On the contextualizing data, better AI outcomes, the business case here could be more of a risk use case, right? It's both risk and opportunity. So on the risk side, everyone knows that AI is this disruptive set of technologies, and it can actually create this existential threat. Nobody wants to become the next, blockbuster being disrupted by, a Netflix or the next Nokia or that's disrupted by Apple, right? So no one wants to be the disrupted company, and AI has that disruptive power. So what is the cost of doing nothing? If we just sit back and wait, will another competitor or some other organization come in with AI and disrupt us, right? So it's this existential threat. So what are we doing to prepare for that? And AI success is going to start, as Sumit had mentioned earlier, it starts with the data, right? And having our data of high quality, contextualized, ready, AI ready, that is a key element of the business case here. And the last one is around the massive cost savings. So in this case, we're talking about eliminating that bad data tax. So you might be able to say, well, what is our current annual IT spend? And let's take kind of the lower end of that range of what bad data tax impact is. And so if we say, what's 40% of our annual IT spend? And what if we could reduce that bad data tax by 50% in the next 2 years? What would be the impact on our organization? And I think if you do the math, the ROI on this is really off the charts. So if you're looking for how do I make the case to senior management, I think this is definitely one of those areas that you can start. So with that, where does GraphWise fit into this? And I'll turn this over to Sumit.
Sure, thank you, Brandon, for explaining those use cases. These are very interesting. So yes, a quick blurb on what is GraphWise, right? And GraphWise is an AI company that is the merger of erstwhile Ontotext and Semantic Web Company, SWC, both pioneers in their respective fields. And the whole idea of forming GraphWise is to let enterprise connect the dots across the data through graphs, to combine domain knowledge and diverse data into a holistic view, right? SWC, Semantic Web Company, has deep expertise in knowledge engineering, in intelligent document processing, while Ontotext excels in building graph databases with NLP and semantic data integration at scale. SWC was named as one of the top KM World top 100 companies in the knowledge management field, and also is a sample vendor in Gartner's Hype Cycle for generative AI in 2024. And this is sort of a strategic move, because what we have realized is that as AI continues to advance, demand for high quality data and explainable models will become critical. So GraphWise's promise is to bring in confidence when you're building with AI, helping LLMs ground with multimodal data, structured, unstructured, helping improve AI performance, the ROI on AI, lowering your total costs of ownership. I recently wrote a blog about how you can lower your total cost of ownership with AI using knowledge graphs, and also improve accuracy and promote better search and recommendation results. So GraphWise, in short, delivers a knowledge graph infrastructure to ensure enterprises are ready to realize the potential of the data that they have with AI. And from the perspective of customers and prospects, customers will benefit from an expanded set of use cases through this merger and a comprehensive solution for building and managing knowledge graphs. I think we go to the next slide, which I think I've sort of already covered, where we are targeting the graph and the AI market with all these different capabilities. One coming from the Ontotext side, the pink side, and the merger with SWC, which is bringing in a lot of capabilities to manage taxonomies, to manage ontologies, the whole area of knowledge engineering. Now, coming to last few of the final slides, this is a big picture of where knowledge graphs are positioned in the overall data ecosystem within an enterprise, right? This is a little busy diagram, but let's quickly break it into simple pieces, right? At the center, we see a knowledge graph powered unified conceptual model that includes ontologies, schemas, reference data, vocabularies, domain knowledge, and this is all stored in the semantic graph database. This knowledge model makes it very easy to discover and analyze, interpret, search the data across hundreds of IT systems. This is a very versatile approach, in my opinion, because it supports two major design patterns, right? One is the semantic knowledge hub on the left-hand side, which is more working with unstructured data, and then the semantic data fabric on the right-hand side. The knowledge hub, which is on the left-hand side, uses knowledge graphs to manage documents and unstructured content to improve the way relevant documents are found and recommended, summarized, classified. And on the right-hand side, we have the semantic data fabric, which is working with structured data to bring in a unified data access across multiple databases. And if you follow Gartner recently Gartner also said that data fabric needs to encompass both structured data and unstructured data to be successful with your AI endeavors. And the advantage of this kind of a pattern or a design is it promotes ease of use, reuse, consistency, and shared definitions. The semantic layer at the center, powered with knowledge graph, provides visibility, accessibility, and interface to integrate with a variety of data applications and third-party tools, and build that broader context on top of granular data concepts and promotes integration. This unified conceptual model promotes also data hygiene and data validation. So overall, this domain model brings in and unifies the meaning of key concepts and vocabularies and serves as sort of the reference data for the organization. So that's where this gives a very quick overview of where knowledge graphs fit into an overall data ecosystem within an organization. And with that, I hand it over to Brandon to do the last few slides and take it from there.
Yeah, we're almost done here. So, how to start your graph COE today. And I've put this into just a 7-step process. So first one is building the business case, right? You have to build that business case to be able to sell this idea to senior management, because ultimately you want to be able to get a sponsor and budget. So building the business case, educating your senior management, and getting a sponsor and budget. Once you kind of hit that, you can move on to the prioritization of use cases. And once you have, you know which use cases, you kind of build a use case tree, you can actually start building the team and upskilling the team. So depending on what your existing graph capabilities are, you may want to do new hires. If you're just getting started, I would say you can also turn to outside help. We've got lots of partners and a lot of companies who can provide services in this space. But then you move on to initiate your lighthouse project. And the key attribute of the first project really needs to be combining the foundation building plus demonstrating a lot of value. So find a good use case along your use case tree that's going to be a great lighthouse project that you can demonstrate the value, build the foundation, start building that foundation. And then the final step is to communicate that success. Make sure everyone understands what has taken place and the value of what it is, and incorporate lessons learned. And then you can kind of continue to move on to go back to the prioritization of use cases and repeat steps 4, 5, 6, and 7. So I hope this has been helpful today. We did, myself, Summit, and one of our other friends at Semantic Arts, Michael Atkin, we developed a white paper, and this is downloadable here at this link starting today. So we're excited to have been able to talk to you today about this topic, and I know we're at the top of the hour already, but I don't know if we have any time for questions, but if we do, I think both of us would be happy to take those.
Well, thank you, gents. It was a very interesting presentation. Yeah, we are actually ahead of time, and I do want to respect people's time. So maybe we can take, you can take 1 or 2 questions really quick, and then the rest you can answer via email, if that's fine. Yep. So there is one, I think, interesting question. I've been feeling a major chicken and egg problem while trying to start a graph initiative from the ground up and my organization. All graph tools such as GraphWise are very expensive, but seem necessary to build even the smallest proof of concept. How does one start in this situation?
So I guess my take on it would be, building the business case first, right? It is the chicken and egg situation, so it is hard. But if you can build a solid business case or find a use case that goes beyond just a typical one graph use case, something that will show the power of having a graph center of excellence, I think that can be very powerful. And then bringing that to your senior management and helping them catch the vision. I've been very impressed that if we can learn to speak the language of business, at the technical side, that's probably our biggest challenge, is learning to speak their language and put it in context that they will understand. The business value is there. We just need to be able to communicate that. And I think that will go a long way to funding it, funding your first project, or at least funding, getting some initial funding to start the graph COE. And then it's all about showing incremental value and keeping the momentum going. And as you demonstrate more value, that might unlock more funds. So don't feel like you have to boil the ocean. You can take this in an incremental way. But I think beginning with the end in mind, knowing where you want this to end up is really critical. So you don't fall into the trap of just doing just a graph use case that's its own silo, because that doesn't get us closer to the end.
All right, thanks. And just one more question before we go. I would like to know your opinion on the pros and cons of semantic RDF graphs like GraphWise versus property graphs like Neo4j, for example.
That's an excellent question. and I'll field this one, Sumit, since I've been right in the middle of this. So my background, I spent 7.5 years on the LPG side and the last 2 years on the RDF side. So I would say, look, I think there's value to both. They're optimized for very different use cases. So if you were to go back, if we were to look at the use case trees, I would say most of the labeled property graph use cases are going to be the very far downstream ones, the ones that are kind of the smaller branches. And that's not to say that they don't add value, because I think they do. We've talked a lot about the better together story, that if you've got, let's say, a label property graph use case that's downstream, it benefits tremendously when the data is contextualized and integrated with shared models. All of that comes from the RDF side, it benefits from that when it's a downstream application. So if they're able to take that, we'll call it the enriched higher value data, and use that in their graph, then they're not just a graph silo, right? So otherwise, every LPG use case ends up being just another graph silo in the organization. But it's the RDF side that really pulls it all together, creates the unified models, and adds the value to contextualizing the data with the ontologies and taxonomies, and even the unstructured data. That's all kind of in the wheelhouse of the RDF side. So I think any good graph COE is going to have expertise in both, but part of the need there is to understand what is optimized for RDF and what is optimized for LPG, and then being able to appropriately select the right technology for the right project.
All right, thanks. And maybe one last for Sumit, I guess. Can you please talk about how do you map the large text and semantic web and create ontologies? Sumit, I think you're muted.
Sumit, we still can't hear you if you're talking.
Can you hear me?
Yeah.
Oh, now there we go.
Yeah. So Yasin, what was the question? Sorry about that.
Can you please talk about how do you map the large text with semantic web and create ontologies?
Yeah, there are a lot of tools to create ontologies, right? And there are a lot of well-known vocabularies and ontologies out there just like public data sets. They're available there that you can incorporate. We also have our own tool called Metadata Studio that helps you to overlay ontologies and taxonomies on top of your unstructured data that could be coming in from text files, from PDFs, from your content management systems, from SharePoints. And ontologies pool party is sort of the tool that helps for building taxonomy and ontologies collaboratively, and bringing in external ontologies that are relevant to your domain. A lot of organizations are sometimes very they stumble in the first step, which is, where do I get my ontologies? Do I start from scratch, right? No, you don't. There are, this is a very mature field where there are a lot of ontologies, vocabularies, reference data that is available in public that you can quickly bring into your systems and start using it and link it to your data sets. Yeah, this is a short answer, but if you like to see a demo or get to understand this in more deeper, we'll be more than happy to schedule some time with you.
All right. Thank you, Sumit. Thank you, Brandon. There are a lot more questions, but those will be covered via email because we don't have time to do this now. Let's respect everyone's time. Just a quick note that the recording will be shared because I saw a couple of questions for this, and also the slides, we can also share the slides, right?
Yeah, of course.
Okay, so we will also share the slide. So thank you everyone for joining. Thanks the speakers for presenting, and see you on the next one.
Sounds good. Thank you.
Thank you, everyone. Thank you, Brandon. Thank you, Yasin. Take care.
Bye bye.